Honeybee is very successful in its own world. It has the right kinds of cognitive capacity to deal with flowers, to deal with something else. And primates are dealing with a completely different environmental context.
Hi, welcome to The Echo. Everybody knows that bees make honey, but what else do they do for us? In today's episode, we explore the relationship between bees and people.
Let's take a trip to your local grocery store to see what a world without our pollinators might look like.
You may be surprised to know that our bees and other pollinators play a role in producing our apples, tomatoes, grapefruits, avocados, mangoes, kiwis, lemons, and even our limes. But that's not all. Our strawberries, blueberries, raspberries, and blackberries, those would be gone too. Even our cashews and our almonds depend on bees.
Bees and pollinators play a huge role in the food that we eat. But what else can bees help us to understand? For a better idea, we went to Colorado State University to speak with Professor Dhruba Naug.
I'm Dhruba Naug, and I'm a faculty in the biology department in Colorado State University. And my research interests are sort of centered around animal behavior, behavioral ecology, and evolution. And I sort of work with honeybees as a model system. And that's sort of the experimental system I use to answer the kind of questions I have.
Can you talk a little bit about what the work that you're doing right now is using bees as a model system?
Right, so the question has been so-called, what's the conflict between your individual interest and what you contribute to the colony? If we are two individuals putting our resources into a group, then the things that if you need less to get by, you can afford to put more into the group than me, who needs more to get by. Mm-hmm. So our contribution to the group level property need not be equal. I'm interested in asking the question that if you have these various individuals with various different genetic components, that might lead to different kinds of behavior. One bee has, some kind of genetic component, another bee has another kind of component. So it is not necessary that these two bees would have exactly the same interest or the same amount of so-called investment in the colony.
One bee in the colony is vital to its success, the queen. Here, Dhruba explains how he uses the queen to set up the colony.
So the bees can sort of chew through it, eat through it, and release the queen gently. And basically there's just candy stuffed in it, sugar candy. So because if you release her suddenly, she might fly away or something like that. So you basically let everybody settle down, eat through this.
Okay.
And within maybe a day or two, she will be able to come out.
Okay, and the queen is in there?
Yeah, so that's the queen. She's slightly bigger. So what you do is you basically stick her a little bit into a frame like this, and then you will dump the bees, and as I'm saying, within a few days she will be able to come out.
What do you think the overall implications of this work are?
The other kind of stuff we did was in terms of disease transmission. So basically what you want to understand is that in a group, how does a disease sort of move? So for example, if one kid gets measles in a school, should we sort of look at dynamics from a very average sense that each of us sort of contribute equally to the disease? Or should we sort of look at it from a kind of a very skewed perspective that some people are more responsible for spreading a disease than some other people? And it is important because if you are thinking about how to control the disease, how a disease would spread in a group of 10 shy people versus 10 very interactive social people. And again, basically using the bee colony as a model because you can manipulate the system.
You've told me before, but it's important that you didn't necessarily choose to work with bees, that you had this idea and bees were the model that worked best. So can you talk briefly about that?
It's really nice to have a system where you can do hard experiments. That's one way to do biology, is chase animals. Some people are excited by dolphins and they go and study dolphins, and they want to study lions, go and study lions. So that's one way to do behavior, is that you chase an animal.
Yeah.
Or the other perspective is that you take a question and see what's the best model system to answer the question. When I had interviewed for my grad studies, I talked about being interested in questions about social behavior, being interested in questions about senescence, questions about foraging, decision making. So the idea was that, if you're interested in this and if you're interested in the question, you should be looking at, something like a honeybee or even a fruit fly. So we have sort of these questions about social behavior and decision making. And honeybees, the nice thing is you have individuals, but they also live in a group. So you can actually look at both so-called processes, both at the individual level and at the group level. I think I got some good advice at some point, and it really convinced me that yes, actually that's not a bad way to think about it, is that if you have these questions, how hard can you come at those questions, using a model system in the lab where you can sort of control, manipulate everything, rather than, watching from a mile away, then making inferences about what might be going on.
Yeah. Okay.
I mean, this is how we buy them, this is how beekeepers buy them. So it's about 3 pounds of bees, 1 queen. This year it's costing around, I believe, $120 each.
$120 for that?
Yeah.
Okay.
So you have a cluster of bees. This is a queen cage with the queen inside it. And this is basically a feeder with sugar syrup in it. So the way that's how, so these come from California, the way they're bred. And this is how, basically bees go all over the country.
Okay. Do you think that the public's perception of cognition should change?
There is a lot of controversy about, how do we even define what is intelligence? I mean, that word itself might be a little anthropomorphic, so-called. You have to really understand intelligence from a very ecological perspective. So it is, in fact, comparing apples and oranges if you're trying to compare a primate with a honeybee, let's say. Because honeybee is very successful in its own world. It has the right kinds of cognitive capacity to deal with flowers, to deal with something else. And primates are dealing with a completely different environmental context. So let's just say that honeybees are smart in their own way, and primates are smart in their own way. Let's not try to compare this, because the argument is that it's not probably very fruitful trying to compare animals at very different levels, because they are dealing with very different challenges. And your cognitive capacity is only evolving to deal with that set of challenges. In order to understand overall the structure of the world, you really have to appreciate evolutionary theory, because that is what, in some sense, is the most fundamental idea, which is sort of defining the structure of the biological world. There's this famous Dobzhansky quote, which says, nothing in biology makes sense except in the light of evolution.